Hello dear viewers, today we shall be looking at the number system. But first, welcome to Pratek IT Solution. And if it is your first time being here, make sure to like, you subscribe as we go on. Now, with the decimal number system, we have 10 values. With the binary number system, we have 2 values, 0 and 1. With the octal number system, we have 8 values. It starts from 0 to 7. And with the hexadecimal number system, we have 16 values, that is base 16 from 0 right to F, where 10 is represented as A, 11 as B, 12 as C, and 15 as F. So we shall be looking at conversion. We shall convert from decimal to octal, from decimal to binary, from decimal to hexadecimal, and all the like. So make sure to like, make sure to subscribe, and to share the video. Now let's begin from decimal to other system. Now we shall talk about the decimal that is in base 10 to the binary which is in base 2. Now let's take, for example, we have 25 in base 10. We want to convert this value to base 2. Now we should recall that there are only 2 values in the binary system, which is 0 and 1. So doing that, we have 25 divided by 2. And here we are going to write the remainder. So what is 25 divided by 2? We are going to have 12. We take 12 again, we divide by 12, remainder 1. Here we write the remainder. And what is 12 divided by 2 again? We have 6. And what is going to be left? 0. 6 divided by 2, we have 3, remainder 0. 3 divided by 2, we will have 1, remainder that, and right down to the end. So now we read the results from bottom to up, that is from 1 1 0 0 1. So we will have this as our result. Therefore this will give us this. So as an exercise 1, we convert 34 base 10 to base 2, and you leave your answers in the comment section below. I'll get back to you to verify if you're on the right track or not. Now let us now go to decimal to octal. Decimal is in base 10, octal is in base 8. We shall do the same thing, but now we shall be dividing by 8. Let's take, for example, we have 137. We want to convert 137 to base 8. We divide by 8 and we write the remainder over here. So now we will get 17, remainder 1. 17 divided by 8 again, we have 2, remainder 1, and 2 divided by 8 is 0, remainder 2. We read the results from bottom to top. So we will get 2 1 1 as our result. So if we convert this value 137 in base 10 to base 8, we get 8. Therefore, as exercise 2, you convert this 56 base 10. I want to see the answer in base 10, and you leave your answers in the comment section below, and I'll get back to you. Now from decimal to hexadecimal, we do the same thing, but now we are dividing by 16. Now let's take, for example, we have 223 base 10. We want to convert this to base 16, meaning we need to divide by 16, and then we write the remainder over here. Now as we are dividing, if we divide this with this, we have 13, remainder 15, and 13 divided by 16, we have 0, remainder 13. Now we read our results from bottom to top as usual. So we have 13 and 15, but we need to recall that 13 in hexadecimal is G, while 15 is F. Therefore we have this as our result, GF16. So we take this as our next exercise, exercise 3. Convert 344, which is in base 10. I would like to see the answer in base 16, and you leave your answers in the comment section below. Therefore, our golden rule number 1, when converting from a decimal number to any other base, we continuously divide the number by that base and write the quotient at bottom. We write the remainder at right until we get 0 at the bottom, and then we read the result from bottom to top. Now from other base to decimal, we shall begin with from the binary to the decimal number base. So now let's take, for example, we have 11001 in base 2. We want to convert it to base 10. What do? we simply write the numbers and we begin from 0 and we are increasing the power 0, 1, 2, 3 and 4. So now what do? We now take this 1 times 2, which is the base, raised to the power 4, plus this 1 times 2 raised to the power 3, plus this 1 times 2 raised to the power 0. Now anything times 0 will give you 0. That's why we do not include this for easier simplification. So if we do all this, we'll get 25 as our result. Therefore, exercise 4, we convert this 1 0 0 0 1 0, or that is in base 2. I would like to see the answer in base 10, and you leave your answers in the comment section below, and I'll get back to you to see if you are on the right track. If there's any question, make sure you post them also in the comment section. Now we will convert from octal, that is in base 8, to decimal, which is in base 10. Now taking the example 2118 to base 10, how therefore do you go about this? Now we have 211, which is in base 8. You write by increasing the powers from 0, 1 and 2. So now this is what we get: 2 times 8 raised to the power 2. This 2 times the 8, which is the base, raised to the power 2, plus this 1 times 2 raised to the power times 8 raised to the power 1, plus this 1 times 8 raised to the power 0. So if we simplify all of this, we'll get 137 as our result. Now exercise number 5, we'll convert 7448, which is in base 10. I would like to see the answer in, which is in base 8. I would like to see the answer in base 10. Make sure to leave it in the comment section below. Now from hexadecimal to decimal, example, let's convert GF, which is in base 16, to a number in base 10. Now we should record that GF is 13 and 15. G is 13 while F is 15, as we earlier said in the beginning. Now while increasing the power of this, we have 0 and 1. Therefore we have 13 times 16 raised to the power 1. This 16 is the base, this is the 13 here, and this one belongs to the power, the exponents we gave it, plus this 15 times 16 raised to the power 0. So simplifying this, we'll have 223 as our result. And as exercise, we'll get we have 744 base 16. I would like to see this in base 10. We do the same, we leave our answers in the comment section. Therefore our golden rule number 2 will be to convert from any base to base 10. We scan the number from right to left. We take the right last digit, multiply it by that base to the power 0. We take the digit to the right, multiply by that base to the power 1. Keep on repeating the steps while increasing the exponent. The final addition result is equivalent to the decimal number. Now we shall now go ahead to convert fractions. Now let's take, for example, we will be doing from base 10 to base 2 in fraction. So now if we have 62.625 in base 10, we want to convert this to base 2. Now the fraction here represents this 0.625. This is the fraction part we are talking about. Now we already know how to convert from base 10 to base 2. Now if it now includes a fraction, as we can see here, we will start by converting the integer and then continue by converting the fraction. Now beginning with the integer, we have 62. We convert this to base 2. We divide by 2 as we earlier saw. So we write the remainder over here, and we get this as our result. We have 1111110, and we read the answers from bottom to top. Now continue now with the decimal value. With the fraction, we have 0.625. we multiply by 2. Here we were dividing by 2, but because it is a fraction, we multiply by 2. We have 1.250. We continue again. We take now just the fraction. We multiply by 2. We have 0.50. We consider the fraction again, which is 0.50. we multiply by 2, we have 1.00. Now the fraction here is already 0, and anything times 0 is 0, so we end at this level and we read the results from top to bottom, unlike the integer whereby we read the results from bottom to top. With the fraction, we read the results from top to bottom. So what will we get? We have 101. Therefore this is going to be our result. So our exercise number 7 will be to convert 2.47 in base 10. I want to see that in base 2. And our exercise 8 will be to convert this to base 2, and we leave all our answers in the comment section below, and I will verify and get back to you. Now from decimal to octal fraction. Now let's take for example we have 29.30, which is in base 10. We want to get that result in base 8. Then we have 29, we divide that by 8, and then we write the remainder over here as we earlier saw. So if we do that, we will have from our 35 as our result, 3 and 5, which is in base 8. Then now considering now the fraction, what are we going to get? We have 0.30 times 8, we have 2.40. We consider the fraction again, which is 0.4 times 8, we have 3.2. 0.2 times 8, we have 1.6. 0.6 times 8, we have 4.8. Considering just the fraction, we get that. Now we already have up to 5 decimal places here. We can end at that level, and we read the results as we earlier said from top to bottom. So we will get 23146, 23146, all that in base 8. And then if we combine now the results, this results here with these results here, you will get 35.23146, all that in base 8. Therefore we have successfully converted a fraction which is in base 10 to base 8. Exercise number 9, we convert this to base 8, and exercise number 10, we convert 0.878, which is in base 10 to base 8, and we leave all our answers in the comment section below. I'll verify and I'll get back to you to see if you are on the right track. Therefore our golden rule number 3 would be to convert any decimal fraction to any other base in a fraction. We simply convert the integer part, then we take the fraction part and multiply by the destination base. If the newly generated number has a fraction, again we take the fraction and do the same. We keep repeating the above steps until we get 0 as a remainder. For the fraction, we read the results from top to bottom. Now other fractions to decimal fraction, we shall begin from octal fraction to decimal fraction. For example, if we have 45.352 in base 8, we want to convert this to base 10. How do we go about it? We simply write the values as you see here without putting the point, and we calculate how many fractions are here. We have 1, 2, 3. Therefore we begin with the negative power of 3, and we increase right up to when all the numbers are exhausted. As you can see here, we are doing this because it is a fraction, and if we multiply as we earlier did, you have 4 times 8 raised to the power 1 plus 5 times 8 raised to the power 0 plus all of that. And what will be our answer if we do all the mathematics? We will get 37.457. Therefore 45.352 in base 8 will give us 37.457 in base 10. Therefore our exercise 11 will be to convert 35.54 base 8. We'll convert that to base 10, and we leave our answers in the comment section below, and I'll verify and get back to you. Now from binary fraction to decimal fraction. Now for example, if we have this, we want to convert this to base 10. This is in binary, and we want to get this fraction which is in binary to base 10. How do we go about it? We simply do the same thing we earlier did. Since there are 3 fractions here, we begin with the negative power 3. If there were 4, we begin with the negative power 4, and we add right up to when all the numbers are exhausted. Now if we do the calculation, the mathematics, we'll get 18.625 as our answer. Therefore, converting this value in base 2, it will give us 18.625 in base 10. Therefore, our golden rule number 4 is the same as our golden rule number 2. Go back and then we read golden rule number 2. Therefore, interconversion between bases. This part is very important. Now, if we want to convert from binary to octal, for example, we have all of these numbers here, all of these binary numbers here. We want to convert this to base 8. How therefore do we go about it? Now we group them in 3 parts. That is, we take each the digits, we group them in 3s. We have 1, 2, 3. We begin from our right to the left. We group the first 3, as you can find here. We group the next 3. We group the next 3 until when all the numbers are exhausted. Now, if you discover here the numbers were exhausted, we simply add 0 to the left. Now, converting this number now in octal, what will it give us? If you convert this number in octal, it will give us 1. If you convert this to octal, it will give us 0. If you convert this to octal, it will give us 1. If you convert this to octal, it will give us 6. This to octal, it will give us 5. And this in octal, it will give us 7. Therefore, from binary to octal is a combination of all of this, as you can see here. 1.100101657, ordered in base 8. Now, example number 2. If we have numbers like this, we have 11001101.101, ordered in base 2 to base 8. How therefore do we go? Now this is a fraction. Now it is simple. We simply group them still in groups of 3s. Here we group 1, 2, 3. We leave it here, and we group the next values. All of these we group them in 3s. Now this here will give us 6. Here it will give us 7, and here it will give us 5. So therefore it will give us 67.5, as you can find in base 8. Now let us convert from binary to hexadecimal. Now if we have binary to hexadecimal, in octal we group in 3s. Now in hexadecimal we will group them in 4s. Now how do we group them? We begin from right to left for integers, as you can find here. We have this, which is the first 4 digits. Continue with the next 4 digits. We continue with the next 4 digits. And this in hexadecimal will give you 8. This in hexadecimal will give you 3. This in hexadecimal will give you 10. This in hexadecimal will give you 15. We record that 10 and 15 in hexadecimal. We have A and F. Therefore, we have 83A5. 83A5. 83AF, ordered in base 16. Therefore, this is going to be our result. Now, as an exercise, we'll convert this to base 16. Now, as hint, we need to know that we need to group in groups of 3, in groups of 4s. Now, instead of adding the 0 at the end, we know exactly where to add the 0, so we should not be confused. You do it and you leave your answers in the comment section below. We group in 4s. Therefore, our golden rule number 5 will be to convert from binary to octal. We scan the integer part from right to left and group digits by groups of 3. Now we write the equivalent of each group. For fraction parts, scan from left to right and do the same. That's the difference. We scan from left to right and do the same. If digits are insufficient for grouping, add the required numbers of zeros to extreme left for integer parts and extreme right for fraction. This number 4 is very important. This is the hint for you to do exercise 11. Now, why are we grouping them in threes for Octal? Now, we use groups of 3 in Octal because it takes a maximum of 3 binary bits to represent any octal digit. And why are we grouping them in groups of 4 for hexadecimal? It's still for the same reason, because it takes a maximum of 4 bits to group to represent any octal digit. That will be all for today. Make sure to visit my website at gametech.com, and for my YouTube you can get me at Bratech IT Solution. That will be all for now. Stay safe.